Where did the sun come from? How did Uranus get knocked on its side? And why isn't Pluto a planet anymore? Today we're going to be using an awesome program called SpaceEdge to explore today. Hi, my name's Max, and welcome to Zero G Stargazing. I hope you're all excited to talk about the mysteries of the solar system. Hop on in your spacesuits and buckle up, and let's get started with a super fun look at our tiny little corner of space, right now. The sun is a star just like all the other points of light you can see in the night sky. There are some planets and satellites up there, but for the most part, all the lights you see in the night sky are stars not too different from our sun. The big guy right here is what astronomers classify as a yellow dwarf. I know he doesn't look too small, but compared to some of his friends around the galaxy, our friend the sun is truly tiny. Our sun started out as a big cloud of hydrogen gas and dust, known as a nebula, and after millions and millions of years, the gas and dust condensed into what we know as the sun. And all the leftover material formed the rest of the planets. Our friend the sun gets its energy from a process known as fusion. At the center of the sun, where pressures are immense and temperatures can reach as high as 27 million degrees Fahrenheit. In those conditions, atoms are really bad at social distancing, and some of them smash into each other. When hydrogen atoms hit each other and their nuclei collide, they make a new element, helium, and a bunch of energy and light. This energy, that is made in the core of the sun, is what the sun uses to fight off the force of gravity trying to collapse the core. Eventually, stars will run out of their hydrogen fuel, and much larger ones will explode in huge events called supernova. These events are where we get elements like calcium, potassium, and iron. In the cores of dying stars before they explode, we get elements like oxygen, nitrogen, and carbon. All of these elements are in your body right now, and the cool shiny metals like gold and platinum are formed when stars collide together. The universe is truly a hectic place to be. Luckily for us, the sun isn't big enough to explode, and it's got about 5 billion years of fuel left, which is more time than the Earth has even existed. First up on our planets list is going to be Mercury, named after the Roman messenger of the gods. When I talk about Mercury at the planetarium, I like to ask people what other objects in the night sky Mercury reminds them of, and what most people say is the moon, which is true. They look alike because they could almost be twins. The reason the moon and Mercury look so much alike, unlike Earth, neither have an atmosphere or active geology, so for billions of years, Mercury and the moon have been bombarded by asteroids, and because there is no wind or rain, all of these craters get preserved forever. While Mercury might look dusty and boring, the planet actually holds some pretty cool features. Mercury is what astronomers call a 3-to-2 orbital resonance, which simply means that if you were to take a trip to Mercury, you would only see one day for every 2 Mercury years. But don't worry, 1 year on Mercury is only 88 Earth days. However, for us Earthlings, it would definitely be quite disorientating. Did you know that despite being so close to the sun, astronomers have been able to find ice in the craters in the North and South Poles? This is because Mercury has the lowest tilt of any planet, only 2 degrees off, meaning that some craters on the poles have never seen sunlight. Mercury is a great example of not judging a book by its cover. Even the most inconspicuous space rocks might have some secrets hiding somewhere. Venus is next on the docket, the Roman goddess of beauty, sometimes referred to as Earth's twin due to their closeness in size. However, I always like to say that Venus is more like Earth's third cousin twice removed. A quick look and you can't really see much behind a tannish beige orb. What we're looking at is Venus's incredibly thick atmosphere. It acts like a blanket around the planet, heating it up to insane temperatures and creating a massive amount of atmospheric pressure on the surface. If we were to land a spaceship and have a brave scientist step out on the planet's surface, they would only last about 2 seconds, as pressures would be equivalent to being 3,000 feet below the Earth's oceans. And if being a human pancake isn't good enough reason not to go to Venus, a nice summer's day is a measly 800 degrees Fahrenheit. I don't know about you guys, but if I'm going to be a human pancake, I would at least want to be a well-cooked one. Even probes that have been sent to the surface haven't fared too well. If they can survive the temperatures and pressures, the sulfuric acid rain ensures that probes don't last. However, radar has allowed us to image the surface with great accuracy, allowing us to see large volcanoes, over 150 of which are over 60 miles across, larger than the biggest volcanoes on Earth. Many aspects of Venus are still shrouded in mystery due to the intense conditions found there, but if we have the will and the engineering power, we should be able to visit Venus again. Next up is Earth, the only planet not named after a Roman god. Earth is unique in the universe, being the only planet that has developed life. During shows in the past, I've asked people to name off things Earth has that other planets don't. Some of the usual answers are things like life, humans, trees, and water, which isn't quite right, but we'll talk about that in a bit. But the answer that stuck with me the most was a 6-year-old who loudly yelled out that Earth was the only place with cows, which slightly derailed the show for a minute, but technically he is right, we are the only place with cows. And those are the best kind of answers. Many people and scientists speculate that there is life out there all over the universe, and looking out at the night sky and seeing all of those stars, it's hard not to imagine alien worlds out there in the cosmos. But what is fascinating is there might even be some places in our own solar system that could harbor life. Even the smallest single-celled bacteria would be one of the most groundbreaking discoveries in human history. Taking a quick pit stop at the moon, we can see that it does in fact look a lot like Mercury. However, for a very long time we were unsure of the origins of the moon. It wasn't until the Apollo 11 missions, where they brought back samples from the moon, that we were able to realize that the moon was formed from the same material that the Earth was. Later, we speculated that a large object collided with the Earth many billions of years ago, and the debris from that collision formed the moon. The longer story is really fascinating, and it's a story of our early solar system, and we can talk about that later. The last rocky world in the solar system, Mars, named after the Roman god of war, sits roughly 150 million miles from the Sun, sometimes called the Red Planet because of its rusty red soil. Mars has captured humans' attention since the advent of the telescope. The canyons on Mars were once thought to be alien canals, and for a very long time it was taken as fact that Mars harbored an alien civilization. Later on, we realized those canals were actually massive canyons, the largest of which, Valles Marineris. The valleys dwarf the Grand Canyon in size. If it were to be laid over the United States, it would reach from Los Angeles all the way to New York City, 3,000 miles away. In fact, Valles Marineris is the largest canyon in the entire solar system. Mars is also home to the solar system's largest, albeit dormant, volcano, Olympus Mons. If placed on Earth, it would cover all of France, and its height 2.5 times the size of Mount Everest here on Earth. Mars is a cold desert with an average temperature of only -80 degrees Fahrenheit, with a thin carbon dioxide atmosphere. You can see on the north and south poles there is extensive ice caps. However, this ice isn't made from water. It is formed from carbon dioxide that is frozen out of the atmosphere and come down as snow. And even more exciting, recent findings from our rovers on the ground have found evidence of subsurface water flows. Leaving the planet for a moment, we can take a look at Deimos, in myth, son of Mars, and in astronomy, one of Mars's 2 moons. Both are very irregularly shaped, looking a lot like a potato. The reason being is the moons are so small that they don't have enough gravity to turn themselves into a sphere. The most likely explanation for the existence of these 2 moons is that they were once asteroids, just passing a little too close to Mars, and its gravity scooped them into an orbit. However, the other Martian moon, Phobos, has drifted a little too close to Mars, and the gravitational pull of Mars will rip apart the little moon in about 30 million years, creating a little ring around the red planet. From here on out, the rest of the planets in the solar system are called gas giants, meaning that the planets are mostly made from gas and may or may not have rocky cores. The first gas giant and the largest planet in the solar system is Jupiter, named after the Roman king of gods. A very fitting name if you ask me. Looking at it by itself, you might not be able to get the full scale of the planet. If we look around for a minute, we can find the Great Red Spot. As you can see, astronomers are the least creative people in STEM. This is a massive hurricane in the atmosphere of Jupiter. It has been going on for at least 300 plus years. One of the first people to note the storm was Giovanni Cassini all the way back in 1665. If we were to take the Earth and place it next to the storm, it would take 3 Earths to cover just the distance of the hurricane. In fact, Jupiter is more massive than all the other planets in the solar system combined. The planet, mostly made of hydrogen and trace amounts of helium, which is responsible for the colors seen here. Jovian wind speeds have clocked in at over 300 miles per hour. Yet despite Jupiter dwarfing wind speeds on Earth by over 100 miles per hour, it is on the low end when compared to the other gas giants we will cover later. What astronomers have attributed to this is a massive heat source inside the planet. As you get farther and farther in, pressures start to build and you get more friction generating heat. However, most of this is theory, because strong winds and high pressures of the planet make it impossible to send any equipment far enough into the massive atmosphere. Jupiter was just recently eclipsed by Saturn for having the most moons. Despite Jupiter no longer being the top moon hoarder in the solar system, I think that the planet has some of the most fascinating moons in the solar system. One I would like to highlight is Io. Looking at it, I think it looks sort of like a big booger, or maybe a rotten orange. What is going on is Jupiter's gravity is pulling and tugging at Io like taffy, heating up the rock inside the planet, in an effect known as tidal heating. This molten rock has got to go somewhere, and like other geological active bodies, it exits through volcanoes. In fact, Io is the most volcanically active body in the entire solar system, with over 400 active volcanoes. With all of this activity, great amount of sulfur come out and coat the surface of the planet. So if there was an atmosphere to breathe, and you wanted to frolic around the lava fields of Io, you would have the pleasant smell of hot garbage. So there you have it. Io the booger moon, orbiting the largest planet in the solar system. Flying over to the next gas giant, the universe likes Saturn so much it put a ring on it. Yeah, I'm sorry. That was a bad one. I promise it'll be the last one. But seriously, Saturn is a lot of people's favorite planet because of the giant rings. But all the other gas giants do in fact have rings. It's just the other three planets, their rings are too thin to see with the naked eye. But Saturn's rings are jam-packed with ice and dust. Despite the density of them visually, most of the objects in the rings range from the size of a refrigerator to the size of a piece of dust. And looking at the planet edge-on, we can see the rings are incredibly thin, only 30 feet in some spots. The origins of the ring are still debated, but recent measurements and data suggest they were formed late in the planet's history, possibly from tearing apart a small moon that got too close. Looking at the rings more closely, you can see these gaps. These rings have been creatively labeled D, C, A, F, and G. Seriously, why do we keep talking about the whole naming thing with astronomers? They're not even in the right order. The cause of many of these divisions are due to small shepherd moons orbiting inside the rings. One such moon is Janus, orbiting in between the F and G rings, as you can see right here. There is a delicate balance that exists in the rings, with many moving parts, just like the solar system at large. Moving next to the first of the ice giants, called that because of their distance from the sun, at over 2 billion miles away. This planet has, for many generations of children, been a fun butt joke. Yes, Uranus, or Uranus, which I believe is technically more correct, but whatever brings you joy. What you notice first probably is the beautiful blue color, and no, that's not water. It's actually caused by high levels of methane in the atmosphere, which, in the planetarium, can cause some laughs from kids who know what methane is. Yet, for more interesting than its blue skies and white clouds, is a story about the planet's name. When it was first discovered and recognized as a planet by the astronomer William Herschel, he took it upon himself to name the newfound planet after his new king, King George. You could imagine that a planet named George was not too popular outside of Britain. Yet, for over 70 years, the planet's name stuck, until eventually it was accepted as Uranus, Roman god of the sky. Quite a contentious story about a planet that's so visually calm. Yet, hidden even farther in the past, before there was even life on Earth, a protoplanet slammed into the newly formed Uranus, knocking it over on its side, and dooming it to roll around the solar system, unlike its brothers and sister planets, who all spin upwards. Even farther out yet than Uranus, 700 million miles farther to be exact, lay the last bastion of the solar system, and my favorite planet, Neptune, god of the seas. At this distance, the sun is starting to look more like another star in the night sky than the large imposing orb in the Earth's sky. Despite this distance, Neptune still offers quite a few unique features. First noticed by the Voyager 2 probe in 1988 was a large storm system like Jupiter, called the Great Dark Spot, because, you know, big and dark. Do we expect anything more at this point? Which, at face value, makes a lot of sense. Gas giant with a storm. So what? Well, if we think about what drives storm systems on Earth, things get a little weird. On Earth and other planets, to get large storm systems, you need large temperature differences. But at 2.7 billion miles from the sun, you can't expect a lot of energy to reach you out here. So for astronomers to measure wind speeds of over 1,000 miles per hour, faster than any other planet in the solar system, that tells us that there are secrets in Neptune's core that are hiding deep under the atmosphere. Secrets that many astronomers are eager to study. The outer solar system as a whole continues to be shrouded in mystery due to massive distances needed to travel. One such object that many are excited to get a glimpse of is our friend Pluto. Remember when I asked why Pluto was no longer a planet? Well, for you Pluto fans, we're going to explain it right now. So, back in 2006, the International Astronomical Union got together to redefine what a planet was. This is because, as our telescopes got better, and we kept finding more objects around Pluto that were about the same size. 5 in fact. And astronomers were starting to worry that we might find even more. So they got together and they decided to redefine what a planet was. So those 3 criteria were: 1. It had to orbit the sun. And if we look at Pluto, it does indeed orbit the sun. And 2. It has to be large enough to smash itself into a sphere using its own gravity. Which, if we look at Pluto, again, it does meet that criteria. I'm looking at you, Martian moons. But 3rd, and the reason Pluto is no longer a planet, is that it has to clear all of the debris out of its orbit. And its location in the Kuiper belt means that Pluto has not cleared the debris up. So unless Pluto wants to be a good teenager and clean up their room, he's going to have to be okay with being a dwarf planet. But don't worry. Pluto has lots of dwarf planet friends in the outer solar system. The Kuiper belt, and even farther out in the Oort cloud, offers many mysteries for astronomers to pick through. Past the Oort cloud, we begin to lose the influence of the sun, and we drift out farther and farther into interstellar space. So there you have it, folks. A tour of our little backyard known as the solar system. And as you can see, there's so many stars around our galaxy and so much to discover. So come back next time where we can talk about some more astronomy, and leave a comment below telling me what you want to learn about next. And as always, stay curious and have fun discovering.